Completed a second installment of Chapter 4 problems. The plan was to go to the next section, 4.6, in which I'm about halfway through. But that section is getting so thick with work that I decided to just cut it to this part, to sections 4.4 and 4.5. Yes, I've already read 4.6. This video is going to go out, I think, July 19th, even though date of filming is July 3rd. And then, of course, when it comes to the output, it was a total of 60 problems, and I'm up to 749 problems so far. So, to the book. It's only 2 sections, but boy, was one of them something. Actually, both of them. So it was section 4.4 and 4.5, and these sections are very thick with concepts. The issue of bases, of spanning sets. And so for a basis, you need to have it span the vector space, and also the set of vectors has to be linearly independent. And then you get a little bit of a wrinkle where if then you have dimension, which gets complicated. Actually, I was completely blown away by how complicated the concept of dimension is with all the theorems where you'll have a set that needs to be expanded to be fully a basis, or you have a set that has too many vectors and has to have some vectors subtracted to get down to the basis. But yeah, this theorem is the one. So if you have an n-dimensional vector space and the vector set S has exactly n vectors, then n is a basis for V if and only if S spans V or S is linearly independent. So there's a little wrinkle when you have an exact number of vectors covering the same dimension with the same number of vectors. Whereas before, you really had to have an and. You have to have span and you have to have linearly independence. Now here, you can have one or the other, and the other one comes for free, basically. But yeah, I was very surprised. And also, the latter part of the section on dimension has some proofs. And yeah, actually, I got blown away by these problems. Really did. Matter of fact, this is the only section, the section on dimension, where I've had to check constantly back with the answers to see that I'm going in the right direction. And I got many little things wrong. I understood the basic concept, but it was not a cruise through problems as I have done so far. So yeah, here's section 4.4. And so yeah, some of the easier problems I was able to do just fine. And I was going very comfortably solving the problems. Right, figuring out linear independence, whether it's a basis, do you need to add a vector, subtract a vector. Got a little bit of simple trigonometry wrong. It happens. Hermite polynomials, Laguerre polynomials. Yeah, all this was pretty smooth. Could have done better here. I didn't realize that they meant it had to be both, which I knew from the theorem, but I got confused. It should have been both true. You have to have span and linear independence. My fault. But then when I got into section 4.5, which required a fair amount of reading, and of course, this is whole concept of going to the middle. So really, S spans V, all right, but you remove some vectors to get to the basis, or S is linearly independent and you add some vectors to get to the basis. Plus minus theorem. Yeah, the theorems in this particular section were a bear. So yeah, you start with linear dependencies. You have too many vectors to get to your linear independent vector set spanning S, and you remove some vectors. Or you start with something that's dependent and you keep adding vectors until you get to independent and it spans S. That's the sort of game that you're playing. But yeah, there were little things here and there. And you know, and of course, in figuring out the dimension of m by m matrices that were diagonal, symmetric, or upper triangular, I was in the ballpark, but I focused too much on the actual combinatorics instead of realizing that the problem was actually a lot simpler. It's just n times n plus 1 over 2 for symmetric or upper triangular. I should have, instead of focusing on this, I focused on this and subtracting it from that. Yeah, my fault. Yeah, some terminology that I had to learn as I got problems wrong, which I do not like to do. But yeah, there's going to be sections like that. And of course, when this happens, I'm planning to do a second linear algebra book after this one. So that's just something to remember. Okay, I'm going to have to do a bunch of new problems on dimension, maybe read a couple other books to finally understand the theorems. I understand the concept of dimension, but I don't understand the theorems well enough when I compare it to other sections. So for example, here there was a problem where I got 2 of them wrong, and I was like, man, really? And the book itself, not just the exercise book, but the actual book itself has answers, and they are the same. And I just couldn't explain it to myself. The matrix that the people who worked out the problems work out is not the matrix. I don't get a 0 row for 19, and I do get 3 dimensions instead of 1. And for some reason, they decided in this parametrization that even though x sub 3 is equal to 0, to make it t. That does not jive with anything that I have studied up to this point. So I'm wrong, but I don't see why I'm wrong in either case. But I'll make a note of that. Yeah. So this section was very difficult, the most difficult section to date. And of course, I'm already well into section 4.6.